Does this sound familiar? Yeah. Well, you are right. This is the sound of the ocean waves. Okay, now what about this? Did that sound familiar too? Well, for most of us, not quite. This is in fact another sound produced in the ocean by cusk eels. Cusk eels are eel-shaped fishes that mainly live in the deep sea, ranging from about 1,000 to 5,000 meters. They make pulsed, drum-like calls via specialized sonic muscles that contract against the swim bladder, producing low-frequency purrs that males often use during courtship and spawning, and to communicate with other cusk eels. Interesting, right? Well, I'm pretty sure that most of us have heard this phrase of only 20% of the ocean is explored. Why is that so? The ocean is not fully explored because of extreme environmental conditions like crushing pressure and darkness, the immense size and cost of exploration, and technological limitations such as the inability of GPS and radio to penetrate water. In this video, we will be exploring the ocean acoustics in terms of chemistry, physics, and biology, meaning how the biological, physical, and chemical factors contribute or shape certain sounds in the ocean.
Now, let's talk about ocean physics. You know already that when fish species sound. Does one species only hear the sound from the same species? In fact, all sounds emitted can affect the sound heard or sensed by sea creatures. Cargo ship is an example. It is highly dangerous to the communication of the whales. As ships emit low frequency sound constantly, it makes whales stressed and eventually can cause fatality to the whale. As we have heard, sound is one of the most important aspects in marine life. In fact, it is the main messenger in the sea of most of the species. So, what are the things that can influence the behavior of sound waves in terms of physics? First, it's the temperature. Secondly, the salinity. The saltier the water, the denser the water, and hence can cause sound waves to travel faster. Pressure also takes a big part in the setting of sound wave. Seawater layers and also sofa channels also contribute to the physics of the sound waves. Fun fact about sofa channels: deep in the ocean, there is a special layer where sound can travel really far, even across oceans. This happens because the water's temperature and pressure balance each other, trapping sound waves in the layer. That's why whales can talk to each other over huge distance, and scientists can use it to study the ocean.
Now, I'll be talking more about several chemical factors that affect ocean acoustics. Let's take a look at the key chemical contributors. Firstly, we have boric acid, which is primarily responsible for absorption at low frequencies. Then there's magnesium sulfate, which dominates sound absorption at higher frequencies. Lastly, we have magnesium carbonate, which accounts for a smaller absorption anomaly in the mid-frequency range. We also have acidity of the ocean. Ocean pH varies due to multiple reasons like local conditions, water temperature, and biological processes. However, normally the ocean's pH is about 8.1, which is slightly alkaline. However, due to global warming, the ocean is becoming more acidic. In a process known as ocean acidification, more atmospheric carbon dioxide is being absorbed into the ocean, causing the ocean to become more acidic and decreasing the pH. Thus, at low frequencies, it reduces sound absorption, leading to sound traveling farther and the ocean getting louder. Another aspect
Moving on, we will now be discovering the role of biological properties in ocean acoustics, or in simpler terms, how living things in the ocean influences the way sound travels and behaves underwater. Many marine organisms actively produce sound. This is known as biogenic sound production. For instance, whales and dolphins use echolation, emitting high-frequency clicks and listening for echoes to navigate and hunt. Fish produce sounds like drumming or grunting, usually for mating or territorial defense. And one of the loudest underwater creatures, the snapping shrimp creates an explosive popping sound with its claw. These snaps can raise background noise levels by up to 10 to 20 decibels in tropical coastal regions. That's louder than many ships at close range. Together, all these sounds form the biological soundscape, or biophony, which fills the ocean with a constant natural chorus. Beyond sound production, biology also affects how sound moves through the water. Tiny organisms such as plankton, schools of fishes, and particles of organic matter known as marine snow all interact with sound waves. Some organisms, particularly fish with gas bladders, reflect sound strongly. This is why sonar systems can detect schools of fishes. Other biological particles absorb or scatter sound, reducing its intensity or redirecting it. Because of the distribution of these organisms changes daily, seasonally, and by depth, the ocean's acoustic environment is constantly in motion, quite literally shaped by life. In summary, marine organisms produce sound, scatter it, and absorb it. Sound, in turn, helps both marine life and scientists understand and navigate the underwater world.
In conclusion, the ocean is indeed an orchestra. The physical properties shape the stage, bending and carrying sound. Chemistry tunes the space as pH and bubbles affect how sound travels. Biology brings the music itself, from shrimp crackles to whale songs. If we listen carefully and reduce our noise, we can better map life, track changes, and protect the sea. Thank you.